Hello guys, I am Sir Fritz, your online math tutor in FAST, Fritz Amazing Tutorials. In this episode, we'll talk about using one formula to solve basic math problems related to arithmetic sequence. Again, we'll focus on basic problems in arithmetic sequence. Though basic problems, some conditions present confusions in utilizing the formula to get to the bottom of the solution. Instead of the common formula that you recall when you heard arithmetic sequence, I present this modified formula where I change a sub 1 to a sub k. And to set a common ground, let us define common problems in arithmetic sequence as shown in the table below. In solving problems related to arithmetic sequence, we are asked to find the missing terms like a sub n, a sub 1, or in our formula, a sub k, the common difference or the variable b, and n, which refers to the number of terms in the sequence or the position of a particular term in the said sequence. And to find the missing values for these unknowns, we will be provided with some conditions as shown here. The common formula for the arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times d. Let us have some examples of arithmetic sequence where the first term is 3 and the common difference is 3. So its first 10 terms are 3, 6, 9, 12, 15, up to 30. Where 3 is called a sub 1, 6 is called a sub 2, and so on. In this case, 30 is our a sub 10. But if the 10th term in the sequence is missing, we will call it in our formula as a sub n. The equal differences between consecutive terms of the arithmetic sequence is called the common difference, denoted by the variable d. And logically, n minus 1 times d refers to the number of d's we need to add or subtract to a sub 1 to solve for a sub n. But a confusion on the use of the formula arises when a sub 1 is not even. For example, solve for a sub 10 if a sub 4 is 12 and d is 3. To strictly follow the formula, the students need to find the first term, then continue in finding a sub 10. Hence, there will be two separate computations for this kind of situation. The first solution is solving for a sub 1 to be able to use the provided formula. Sometimes the problem here is that some students are clueless if they need to solve for a sub 1. And even if they did, some of them wonder what formula to be used in order to solve for a sub 1. Well, there could be other methods to use like changing a sub 4 to a sub 1 and a sub 10 to a sub 7 so that we just have to use the formula once. But again, not all may have thought of that logic. To continue, to find a sub 1, we will use the formula by using n equals 4. That is as if you are solving for a sub 4. By substituting all the necessary information, we will get a sub 1 equals 3. Considering that solving for a sub 1 is a success, we can now use the formula to solve for a sub 10. Substituting all the needed information to the formula, we solve a sub 10 equals 30. Now, let us use our modified formula to solve the same problem. Let's solve for a sub 10, where a sub 4 is 12 and d equals 3. In this modified formula, a sub n is the missing term in the sequence. N minus k times d refers to the number of d's that we need to add or subtract to a sub k to solve for a sub n. A sub k could refer to any of the terms before a sub n, or could be any one of the terms after a sub n. Now, let's solve. Note that the given are the following. A sub 4 is 12, hence k is equal to 4, d is 3, and we need to solve for a sub 10. Using the modified formula, let us substitute the necessary information. A sub n is our a sub 10, a sub k is our a sub 4, Then we have 10 minus 4 times 3 as the number of these, or the common difference, that we need to add to a sub 4 to get a sub 10. Continuing with the calculation, we will get a sub 10 equals 30. Our modified formula can also be used when a sub k is found after a sub n in a sequence. Let us try the problem where we need to solve for a sub 10 given a sub 15 equals 45 and d equals 3. Again, using the modified formula, let us substitute the necessary information. A sub n is our a sub 10 and a sub k is our a sub 15. Then we have 10 minus 15 times 3 as the number of these, or common difference, that we need to add or subtract to a sub 15 to get a sub 10. Continuing with the calculation, we will get a sub 10 equals 30. Isn't that amazing? Please let me know your thoughts by writing your comments below. Now, let's have more exercises. In this video, we'll only cover the basic problems by providing an example for each condition presented here. An example for condition 1 were provided previously. Now let's try having an example where a sub k is missing and we are provided with a term and a common difference, or two terms. Let's also try having an example where d is missing and we will be using a given values for two terms to solve for the value of d. Now, let's consider the arithmetic sequence where a sub 15 is 62 and a sub 100 is 402. And our goal is to find the value of the common difference and the fifth term of the sequence. This problem provides an example for both condition 2 and condition 3. In this problem, let us solve first for the value of d. Take note that the given are a sub 15 equals 62, hence k is equal to 15. Also, a100 is equal to 402. A sub 100 could be the last term, or a sub n, or this could be just any a sub k. Anyway, once you get familiar with the modified formula, a sub n or a sub k doesn't really matter anymore. Now, using the modified formula, let us substitute the necessary information. Let us use a sub 15 and a sub 100 to solve for d. Let's say a sub n is a sub 100 and a sub k is a sub 15. Then we have 100 minus 15 multiplied to d as the number of d's being added to a sub 15 to get a sub 100. So continuing with the calculation, we will get d equals 4. As I mentioned previously, it doesn't matter what you choose for a sub n and for a sub k. Consider the second solution where a sub n is a sub 15 and a sub k is a sub 100. Substituting the values to the modified formula and applying the properties of equality, we will get the same answer for d, which is 4. Now, let us continue solving this problem by finding a sub 5. Now that we know the value of d, and we have at least one a sub k, which is a sub 15, and or a sub 100, we can use the process presented in condition 1 to find the value of a sub 5. Using the modified formula where a sub n is a sub 5, or the missing term, and a sub k is a sub 15, then we have 5 minus 15 times 4 as the number of these that we need to add or subtract to a sub 15 to get a sub 5. Continuing with the calculation, we will get a sub 5 equals 22. If you are wondering why we chose a sub 15 instead of a sub 100, that doesn't really matter. So let me show you another solution when I use a sub 100 as a sub k instead of a sub 15. Substituting all the information in the given formula, the answer yielded to a sub 5 equals 22 as well. Now let's have an example for condition 4, where we have to solve for n and we are given with either two terms or a term and a common difference. Consider the arithmetic sequence with a sub 4 equals negative 500 and d equals 7. So what term is 25? In this example, a sub 4 is negative 500, d equals 7, and the value of a sub n is 25. Our objective is to determine what term is 25 in the sequence. Hence, in terms of a variable from the formula, we will look for the value of n. So let us use the modified formula where a sub n is a known and a sub k is our a sub 4. Substituting the corresponding values provided for the variables found in our modified formula, we have a sub n equals a sub 4 plus n minus 4 times d. To go further, we have 25 equals negative 500 plus n minus 4 times 7. Applying the properties of equality, we will get n equals 79. Hence, 25 is the 79th term of the arithmetic sequence where a sub 4 is negative 500, and the common difference is 7. So, in conclusion, instead of using this formula, let us use this modified formula to solve the basic problems related to arithmetic sequence. Please don't forget to comment your thoughts about the content of this video. Do not forget to click the like button, share this video to your friends, and to subscribe to my channel. Thank you for listening.